Welcome back, guys, for episode 5 of successive differentiation. So previous 4 episodes we've studied almost all type of problems in successive differentiation. So today in this episode, so product of trigonometric functions. So let me consider the function given to be y is equal to sine 3x into cos 2x. So this is the given function. So y is equal to sine 3x into cos 2x. So I've written it to be equation 1 as we follow it. So now let's proceed with differentiating. So before we differentiate, there are two possibilities of solving this. So applying product rule, where you retain the first function, that is sine 3x, differentiate cos 2x, and repeat the function of product differentiation of a product function or product rule, we can say. But instead, I'll consider a standard equation. The standard function that I have considered is 2 sine a cos b is equal to sine of a plus b plus sine of a minus b. This is the standard result, as we know. So applying this in the equation 1. So how do you apply this in equation 1? That is the question. So here we can see that in LHS of this function, in the standard equation, we can see there's a multiplication of a constant called 2. So what I do is y is equal to, I'll multiply half into 2 sine 3x cos 2x in the equation 1, giving equation 2. So here you can see that half into is nothing but 1, so which gives back you the equation 1. So there is no change in equation 2. It is similar to 1 but in a modified manner. So this becomes more easier to solve. So now using the above equation, so I can write it to be y is equal to, half remains as it is, so 2 sine a cos b can be written as sine a plus b, sine a minus b. But what is a here? 3x, and b is 2x. So a plus b, that is 3x plus 2x, gives you 5x. So sine a plus b is sine 5x plus a minus b, that is 3x minus 2x, that is a is 3x and b is 2x. So 3x minus 2x gives you x. So sine x. So instead of using the product rule over here, I have simply reduced this product function into sum of two functions, which is a similar function sine x. So which is even more easier. So I'll mark this to be equation 3. Now you have to find the first differential. So differentiating 3 with respect to x, what do you get? The first differential, which is represented as y dash. So you get y dash to be half, that is constant. Sine 5x has the differential, so differential of sine 5x, which is a standard function, which I've told you already, cos 5x. So again differentiating 5x gives you a constant 5, which is multiplied to the function, plus differential of sine x is cos x. So this is the first differential, which I'll mark it to be equation 4. So the first differential was very simple in order to find that. So now the question is to find second differential, which is successive differentiation, which we usually take it. So again differentiate with respect to x again. So you get the second differential, that is y double dash. So half into, the constant is 5. So I write 5 into, so this is a multiply sign, or you can just put a dot also. So 5 into, so differential of cos x is minus sine 5x into differential of 5x is again 5, which is multiplied. So plus of minus sine x. The sign is very important over here, as you can see. So solving this particular equation, I can write the final equation, that the second differential is found to be half of, so 5 multiplied by 5 gives you 25, with a negative sign, that is minus, into sine 5x. Again there is a plus into minus, that is gives you negative sine x. So this is the function which gives you the final answer. So this was the product of two trigonometric functions using some of the basic trigonometric rules. You can make the product rule in the simple form of addition, that is, the given equation 1 was changed sum of two trigonometric functions, which is very simple in performing differentiation. So in the coming next episode, you will be learning some of application of these problems. Application in the sense you have to prove some of the results by using the given equation.